Hey guys, today we're going to be talking about adding and subtracting polynomials. Now, as we know, polynomials are kind of like longer expressions with multiple different looking terms, usually an x squared, an x, and a constant. Now they could be more than that, but for the most part that's what we're going to be seeing. So we want to talk about what happens when we have two separate polynomials that we either want to add or subtract. Well, let's write out two of them. Let's say we have 3x squared plus 4x to the, just 4x, minus 2, and then plus 5x squared plus 9x plus 3. So let's say we have these two polynomials, we want to add them. Now you'll notice I stopped there in the middle and I wrote parentheses around the polynomials. I probably should have done that from the beginning, but slipped my mind, right? Now the important reason that we want to put parentheses around these polynomials, or that we look at them with parentheses around them, is to recognize that these are two separate entities. These are two separate expressions. Because this on its own is a polynomial, this on its own is a polynomial. And we are going to add them or combine them in some way to make a new single polynomial. But right now, at this point in the problem, they're two separate expressions. Maybe it's not going to be that important in our addition problem to recognize that they're separate, but I bet it will when we talk about subtraction here in a minute. So this is probably going to remind you a lot of combining like terms. We want to identify our terms that look the same or have the same variable configuration to them. So if we see that we have a 3x squared here, then we want to be able to identify, are there any other 3x squareds in these expressions, not 3x squareds, but just x squared terms in these expressions that it can combine with. And we notice that right here we have a 5x squared. So what we will do is we are going to take each of these terms and apply the operation between the polynomials to them. So we have a positive 3x squared and a positive 5x squared. We're going to add them. Well, we get 8x squared. As you know, when combining like terms, we always want to add the coefficients, but the variables and their exponents are going to stay the same. So let's take a look now at what else we have here. We have a positive 4x. Do we have another x term in our other expression? We absolutely do. We have a positive 9x. So we are going to add 4x and 9x to get 13x. Finally, we're going to look at our last term. We got negative 2 and 3. We want to add these two terms. Negative 2 plus 3 just ends up being 1. That was a lot easier than you probably thought it would be, right? Like, that's just combining like terms. It's no different than what we've done before. We just have a little bit fancier looking expressions. That's it. But let's talk about subtraction too, because that one's also very important. And it's going to be important that we recognize the difference between addition and subtraction. Let me grab my eraser here. I'll clear this out and we'll write a new one. Let's say 2x squared minus 4x plus 3 minus, I don't know, let's go with 5x squared minus 9x plus 2. Let's see what happens now when we subtract them, how this works differently maybe. Or maybe it won't work differently, we just gotta keep in mind what we're doing with subtraction here. We still want to identify our like terms, our x squareds, our x's, our whole numbers, or our constants. We still want to check those out. So we have 2x squared here and 5x squared here. Now both of those numbers are positive, and under normal circumstances you would think, okay, well, I need to add those. But that's not the case here, because even though both are positive, we are subtracting. We are always going to do the operation that is between the polynomials. We just need to keep the individual signs of the terms in mind. So positive 2x squared minus a positive 5x squared. Well, 2 minus 5 is going to be negative 3. And then, as we know, the variables and their exponents don't change. So that wasn't too bad. But let's take a look at this next one. Negative 4x and negative 9x. So I'm going to write this out for us so that we can really take a look at this. We have negative 4x, and then we are subtracting the negative 9x. So we have a lot of minus signs in here, right? This is why I think subtracting polynomials can actually be a little bit more difficult, because we often end up with situations like this where we're subtracting a negative. Now what happens when you subtract a negative? Exactly. The two lines combine to make a plus sign. At least that's the rhyme I like to use. So we are actually going to be adding the 9x to the negative 4x, despite the fact that we have a subtraction sign here and it's a negative 9x. Both of those work together to actually add. That's why it's so important for us to keep the signs in mind with what we're doing. So negative 4x plus 9x is going to end up being positive 5x. And then finally here, we have a positive 3 minus a positive 2. So this is kind of like that very first step we did. 3 minus 2 gets us 1. Now, one of the reasons that I said it's important for us to keep these in parentheses, to keep making sure that we recognize they're separate parts, is because it's possible if we didn't have them, it would be very easy to look at this and say, okay, well, 2x squared minus 5x squared, negative 4x minus 9x, 3 plus 2. Without those parentheses, without keeping in mind that these are two separate expressions that we're adding or subtracting, it would be really easy just to look at this negative, or this minus sign, being a negative 5x squared. Now, I mean, you would apply it here, you'd get that right, but you wouldn't think to apply this negative whenever you're dealing with the x terms or with the constant terms. So that's why we like to keep it in parentheses, denoting that we are subtracting this entire thing. All three of these terms are going to subtract from their like halves on the first part of it. All three are going to be subtracted. If you have any questions about this, feel free to drop them in the comments below. I'll get back to you as soon as I can. Otherwise, thanks for watching, guys.